satellite just broke apart in orbit. And when I pulled the actual tracking data, there's a very clear moment where something goes wrong. I was browsing LinkedIn when I came across a post from Leo Labs about the event, so I decided to dig into the data myself. Hi everyone, I'm Dr. Amanda Fetch, also known as Dr. Amanda Analytics, and my research focuses on AI and space situational awareness along with orbital debris. Back in January of 2026 this year, I broke down a similar event in one of my YouTube videos entitled Space Force Flags a Starlink Debris Event. Wait until you see the orbit view. And just a few days ago, in March of 2026, I published United States Intelligence Warning on Space Debris Verified with Real Data, another one of my YouTube videos. Now we're seeing another Starlink anomaly. So the question is, does the data support what's being reported? And we can check that out. Now, according to Space News, Starlink-34343 experienced an anomaly on March 29th at about 560 kilometers altitude, resulting in a loss of communications. And according to Leo Labs, tens of objects were detected in the vicinity of the satellite, likely caused by an internal energetic source. Now, they also noted that because of the low altitude, the debris will likely deorbit within a few weeks. So instead of stopping there, let's check the actual data. So I started in SpaceTrak.org, and I searched for Starlink-34343, and I found the NORAD catalog ID, which corresponds to that, which is 64157. And from that information, we could check out the apogee, which was about 576 kilometers, perigee about 549 kilometers, and an inclination value of 97.62, which is right in a dense low Earth orbit region. Now I then used LSAT search and selected a date range around that event. And so that gives us multiple orbital snapshots over time. I exported the 3-line element data and brought it into a CSV file to compare how the orbit has changed. Now the format, as I mentioned, 3-line element, line 0 is the satellite name, lines 1 and 2 contain the orbital data. Now if you want to understand this a little bit deeper, I recommend navigating over to CelesTrak, which can give you a full breakdown to what these numbers correspond to and mean. Now here's what that data actually shows. Before the event, mean motion was pretty stable. There was a value of about a 15.0565. Drag term was very low, around 0.00003. Now that's stable orbit. Now during the event, we had an epoch of 26089.124. Drag jumped to 0.0004878. Now mean motion increased to 15.05784. Now that's a clear spike in drag behavior. Now after the event, the mean motion dropped to about 15.014098. Eccentricity increased to about 0.19254. Now the orbit becomes noticeably more irregular. Now this pattern matters to us. You have stable orbit, you have sudden disturbance, now you have that followed by instability. That's not typical of a collision though. This is consistent with an internal energetic event like a propellant release or a system failure. And that aligns directly with what Leo Labs is reporting. Multiple fragments, internal cause, short-lived debris. So the radar observations and orbital data are telling that same story. And again, this is happening at around 560 kilometers altitude, which is one of the most densely populated regions in LEO, or low Earth orbit. Now, even short-lived debris adds complexity in that environment. So I have a question I'd like you to think about. As events like this become more frequent, should we still treat all our objects in orbit the same? Or should we start prioritizing high-risk behavior using AI and clustering methods? Spoiler alert, that was my PhD research, so I'd love to hear your thoughts on that. And with that being said, thanks for tuning in. Take care.